Hello, today we're going to continue on and start our first unit that actually counts for your grade. This is the first scale for BC Calc. And we are going to focus on basic derivatives. And today we're going to talk about the formal definition of a derivative and use that to find the slope of a tangent line and write the equation of a tangent line and find the instantaneous rate of change. So this is building on what you did in the last unit as far as approximating these things. We're going to start talking about how to use algebra and formulas to actually find those exact values. So remember, we use the slope of a secant line using this formula, essentially the slope formula. This is called the difference quotient, and we use that to approach our point of interest and estimate the slope of the tangent line. Now we're going to call this the derivative. Okay, the derivative of f of x at x equals a is the limit of the difference quotients. This is the slope of the tangent line. So the formula we will focus mostly on is f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a over h. This will require some algebra, so you need to be really careful with those skills. Another form that you will see is f prime of a equals the limit as x approaches a of f of x minus f of a over x minus a. I won't use that as often. This does show up in multiple choice questions. So we're going to use that. As I mentioned, the derivative is actually the slope of the tangent line. So you'll see f prime of a here in point slope form, replacing our m. Everything else is the same. What you're used to seeing is y minus y1 equals m times x minus x1. This is the same thing. You just need to know that the slope of the tangent line is f prime of a, and the a value they give you is your x, and then f of a is your y. So we're going to go ahead and do that. Okay. So find an equation of the tangent line to the graph of f of x equals x squared at x equals 5. The first thing we need is an ordered pair for that point. So we're going to go ahead and just plug 5 in to get 25. So the ordered pair that we're going to use when we write our equation is 525. We're going to leave that for now and come back to it because we also need to find the slope of the line, which is f prime of 5. So f prime of 5 is the limit as h approaches 5 of f of 5 plus h minus f of 5 over h. When I plug this in, I need to use my algebra to simplify carefully. And a lot of times it'll work out nicely, sometimes it doesn't, but we get f of 5 plus h is 5 plus h squared minus 5 squared over h. And using some algebra here, when I multiply this out, and if you need to write it off to the side, you can, 5 plus h times 5 plus h is 25 plus 10h plus h squared, and then 5 squared is 25 over h. Now notice that when I do that, 25 and negative 25 cancel. So I end up with the limit as h approaches 0 of h times 10 plus h over h is the same as saying 10 plus 0 or 10. So this is going to be f prime of 5 or your slope. So let's go ahead and plug that in. So y minus 25 equals m, which is 10, times x minus 5. In AP Calculus, you don't have to simplify it. Leave it like that. Save yourself some time. The answer keys that go with the book, they do change this to slope-intercept form, but I won't typically do it. Okay, let's do another one. This one's a little different because this isn't asking for the tangent line. They just want f prime of 3. So I don't need to worry about my ordered pair. I'm just going to go ahead and plug this in. I'm going to do the limit as h approaches 0 of f of 3 plus h minus f of 3 over h. Now be careful because this actually has two terms in it. So we're going to do 3 plus h squared minus 8 times 3 plus h. Put that in brackets so it's a little bit easier to read. Minus 3 squared minus 8 times 3 divided by h. And I'm going to apologize because I forgot this limit in here. So I need the limit as h approaches 0. And then we're going to simplify. So if I multiply this out, we have the limit as h approaches 0 of 9 plus 6h plus h squared minus 24 minus 8h in that first group. And then we get minus 9 minus 24. And I'm actually going to distribute that negative, so I have negative 9, positive 24. And hopefully you see then we can cancel some. So positive 24 and negative 24, positive 9 and negative 9 cancel, and 6h and negative 8h give me negative 2h. So the limit as h approaches 0 of h squared minus 2h divided by h is the same as the limit as h approaches 0 of h minus 2. So we get 0 minus 2, which is negative 2. So f prime of 3 equals negative 2. On the AP exam, they'll say be careful about circling, because if you circled something that's not actually your answer, that could work against you when they're scoring your test. Okay, let's do the third one. I'm actually going to do a little bit of work and then show you what the graph looks like. I'm going to find this f prime at 2. So I'm going to do the limit as h approaches 0 of 1 over 2 plus h minus 1 over 2 divided by h. And I skipped that first step, and you are free to do that as well. I need to multiply by 2 over 2 in the first fraction and 2 plus h over 2 plus h in the second fraction to get the limit as h approaches 0 of 2 minus 2 plus h over 2 times 2 plus h over h. And this is going to simplify nicely so that I have 2 minus 2 is 0. That's a negative h over 2 times 2 plus h. And then I'm going to actually multiply by the reciprocal here so it's easier to see. So those cancel. So the limit as h approaches 0 of negative 1 over 2 times 2 plus h equals negative 1/4. The reason I'm doing that is when you sketch the graph, and I'm going to go ahead and use Desmos here, it's easier if you have an idea of what the slope is. So we're going to go ahead and graph 1 over x. And then we are going to graph at 1, 1, y minus 1 equals 1/4 times x minus 1. And that should be a negative 1/4 that I typed in there. So here is your sketch. And that doesn't quite work because I need 2 for my x value and 1/2 for my y value. I was looking at the wrong point there. Okay, so there's your graph, and you should be good. Okay, this one's quick. Derivative of linear and constant functions. The derivative of a linear function is going to be the slope of that line, and the limit of the derivative of a constant function is going to be 0. So the derivative of f prime, so f prime of 2 is always going to be that slope because this is a linear function, no matter what your value of x is. And that only happens when this is linear. So you don't have to do any of that work. You just need to know the derivative or the slope of the tangent line is going to be the same as the slope of your function there. Okay, for this one, we're going to do one more and estimate the derivative of f of x equals sin of x at pi over 6. So your trig values are going to come in handy here. So f prime of pi over 6 is going to be equal to the limit as h approaches 0 of sine of pi over 6 plus h minus sine of pi over 6 divided by h. Okay, and we can't simplify this, so you need to make a table like we did in the last unit, using your calculator, and test values on the left side and the right side. So when h is greater than 0, we're going to plug in 0.1, 0.001, and 0.0001. Let's add a 0 there, make that closer. And when I type that in for my h values, I get 0.8635, 0.8658, and 0.8660. When h is less than 0, if I plug those into the formula using my calculator, just changing my signs there, those negative, I get 0.8685, 0.8663, and 0.8661. So you'll notice that the closer we get to 0, the closer our limit gets to, and I'm going to use approximately equals here, 0.8660. Okay, I'm going to change your assignment a little bit here. We're actually going to cross this off. I'm not having you do that. Here's your summary that's also in your book. And we are going to cross off 58, 72, and 73 so that you can focus on just those problems on the worksheet. If you have any questions, do not hesitate to reach out. Have a great day.